Hello again. I hope you are feeling well and fine, and welcome to another session of our April live streaming series about physical AI and NVIDIA with AWS. As we spoke in previous sessions, the NVIDIA's complete stack for physical AI is made of data, training, simulation, sim to real, and agentic orchestration. This stack helps you building intelligent systems that interact with the physical world. In previous episodes of our series, we talked about data training and simulation environments with these cool simulations and these cool demos that Abhishek showed. And if you're asking where are these episodes, don't worry because our chat moderators will post the links for the previous episodes in the chat so you don't miss anything. Speaking about the chat, I would like to remember that this is an interactive session, so please speak out and let us know where you are watching us from, and also let us know at any time if you have a question. I'm going to make the presenters stop talking and bring the question in the video. As the host of this episode, this is my duty. Also, speaking about the chats, we have both AWS and NVIDIA staff monitoring the questions and posting the answers. So please don't feel shy and let's use the chats to make contacts with these fabulous SMEs or subject matter experts here in the video for you. As I said, we are in the episode number 4 out of 5 in our series. So, all right, in this episode, as you can probably tell by looking to the screen, I have the company of folks from the AWS Solutions Architecture team, as well as Dan from NVIDIA. And in this episode, they are going to explore agentic orchestration. So expect learning from our subject matter experts, as they are going to cover things like building agentic systems that might require complexity, agent workflow, agentic framework integrations, and much more. Again, I would like to remember that this is an interactive session, so please bring your questions to the chat and we'll be happy to address as much questions as we can. We have both AWS and NVIDIA looking to the questions in the chat, so please, this is supposed to be an interactive session, not a webinar at all. So do bring your questions, let us know where you're watching us from. My name is Raf Lopez, and I am your host for today. I work in the AWS training and certification team, creating training materials, certifications, and hosting live streamings like this one. Let us know in the chat where you're joining. I already said that. So that said, why don't we start with a round of introductions and go from there? Because Abhishek was on camera for our last episode, but we have two new faces here: Dan from NVIDIA and C2, right? Or how do I spell your name, C2? I would say Chat Chatai. Is that
Yes,
correct?
Turkish
Right,
name.
I got it right. Cool.
You nailed it. You nailed it.
Awesome. So cool. Yeah. Why don't we start with a round of introduction so our viewers know a little bit more about you and a little bit more about Dan before Abhishek starts with a demo.
So maybe I can introduce myself. I'm from Stranded Agents team. We build an agent SDK for developers to build their agents faster, and I'm
Hmm.
working as a research engineer.
Cool. I love that robot behind you.
Yeah,
Like what is that?
it's a G1
It's
Edu.
wearing a lanyard. Is it a
Yeah,
conference lanyard?
yeah, it was from GTC. Uh, we participated the GTC. We
Uh-huh.
had a speak at our theater. Abhishek was also speaking there. So this is from that at that time.
That's great. That's great. All right. And then um,
Yep.
let us know about you. Let us know about what you're going to talk today. So before Abhishek starts.
Yep. Sure. My name's Dan. I'm from NVIDIA. I work on applied research on agentic AI at NVIDIA, but also help around with large-scale training engagements on both the training side of things, but also on the physical AI side of things. So it's nice to be here today.
That's very cool. And Abhishek, you're a streaming veteran. Like, if you want to introduce yourself again, of course, for
Yeah.
people who might missed our first 3 episodes, we're going to post the links in the chat, so don't worry, you're going to have all the content. But introduce yourself, and then you can go from there. And remember, keep your questions bringing, guys, in the chat. I'm going to bring them on the video.
Absolutely, Raf, and thanks for hosting this series. This is, as Raf mentioned, this is the fourth session of this physical AI series with NVIDIA and AWS. And our focus today is going to be more on agentic orchestration pillar, something really new. So a lot of content you will see probably going to come first time in the public space. I'm Abhishek Srivastava. I'm a principal solutions architect, AWS, specialized in physical AI technology. Work very closely with our partner NVIDIA to bring a lot of technical accelerator for our customers to ensure you have a easy path to build your physical AI system. And we are very happy to host today's session. With that being
Great.
said, yeah, go
Yeah.
ahead.
One question like, where are these sessions happening? They are happening every week of April in the same channel where you are watching us now at the same time, 5 p.m. Eastern. And we are going to post the links for the previous one if you want to catch up. So let's go.
Absolutely. And I know there is a lot of questions around the past session, so I will quickly run through those links. So if you can bring my slides. Um, so, all right, let me see if I can. All right. So this is the first session. As Raf mentioned at the beginning, we have this whole five pillar data training, simulation, sim to real, and agentic orchestrations. Today we are talking about agentic orchestration. The session right on screen is the session where we covered the generating the synthetic data with NVIDIA Cosmos at scale. Do check out this link. The second one, which we have, is the QR code, which covered the training pillar of physical AI, which is diving deep on uh, post-training NVIDIA GR00T Foundation model using AWS Batch. We did like really step-by-step process on how to do this. Tons of material for you to consume there. Um, this was our last session where we discussed about the simulation pillar for physical AI with NVIDIA Isaac Sim on Amazon EC2 and showcase how quickly you can stand up the fully functional simulation environment on cloud at scale. So really these sessions I like to highlight is geared toward providing the complete picture of physical AI from synthetic data generation to policy training to for policy validation and then finally to edge deployments. A wealth of content for you here, which we are producing through this series. In today's session, we will be diving deep on agentic orchestration for physical AI automation. Now, sometimes we use the word agentic AI and physical AI and combine them together, creates a little bit of confusion in front of our customers. I will try my best to clarify those concepts before we dive deeper into two key things. Number one, NVIDIA NeMo Agent Toolkit, where Dan, my friend, is going to talk deeper about that one and how this helping our customers to build an agentic orchestration layer on top of physical AI system. And then later, C2 is going to dive deep into the um, Strands agent and Bedrock AgentCore, where we will think about how do we quickly accelerate the development and host these agents for interacting with the physical systems, right? So with that being said, let's quickly glance through the agenda, which you will see today. We will start with the evolution of agentic AI from a digital to physical automation. Probably sounds interesting right here. From there, we will cover the AWS mental model for agentic orchestration, focusing on the physical AI system. We'll dive deeper into NVIDIA NeMo Agent Toolkit, as I mentioned with Dan. Finally, C2 will cover his research and the development around Strands agent to accelerate the physical AI lifecycle. Now, if you are getting started with physical AI, this is a perfect session for you. In fact, this is the perfect series for you. So do check out those links which I shared and follow through the today's session because it will provide some great context about agentic orchestration and how it interfaces with the industry. With that being said, welcome to our agentic AI lab. This is our AWS office in Arlington, Virginia, where we built a really inspiring industrial demo last year. I want to play this demo. Watch this humanoid respond to the natural language prompt. pick up an item from the nearest picking station, and I'll quote nearest, place the item into the empty bin. I'm going to quote empty here, right? Notice there is no pre-program orchestration here. You have a bunch of agents that is working together towards a common goal to complete certain tasks. The agent is parsing the intent, it is validating the inventory, identifying nearest object, and empty stand in real time. Behind the scene, what's happening is there are multi agents, such as the planner agent that decompose all the tasks. There is a perception agent that scans the environment of this agentic AI lab. There is an inventory agent that identify if that specific object was available in the inventory. And then finally, there is a motion agent that executes the work in a physical world. This is agentic orchestration, a specialized agents working together from both digital and the physical world together to offer an industrial scale automation. A very short demo, but it triggers where agentic AI is helping for a larger industrial scale automation. I hope this was able to give some idea where we are trying to head our conversation today, right? So to understand where we are going, let's look into how Gen AI has evolved across 4 stages, each with increasing autonomy and business impact. We start with the assistant. We all know about generative AI assistant at this moment, where you have a tool that follows a set of rule to automate any repetitive task. Like example, you have a chatbot, right? Or you want to do a content generations, which is really helpful. But think through that. As a human, you need to provide the prompt every steps, right? So that takes us to the second point, where we have a single purpose agent, which is designed to achieve a specific goal. So take an example of, like, let's say a digital agent handling the customer refund. Without step-by-step prompting and human in the loop, you given a task or you given a goal, and the digital agent is trying to achieve that one, and that is a generative AI agent. From there, now we entered into this era of agentic system, fully autonomous, multi-agent architecture. They plan, they reason, they delegate, they self-correct like a team of digital worker operating together. So that is an interesting paradigm from where we started in last few years and where we are right now. This is the last one is something my perception. I think this is where we are heading. And we are crossing a critical threshold from a digital world into the physical world. This is where AI stops being a digital tool and become a system that operates along with you. But I'll be honest, we are not there yet. There is a lot of research and developments happening in this space. What I feel is physical world autonomy is going to be an ultimate challenge for agentic AI. So, something to really closely watch in this space. And I'm very excited to be a part of this and help our customers to reach there. I mentioned we are not there yet. So, that means there is some challenges. So, let's dig deeper into these challenges. Digital agent, they operates in a forgiving world, and I was looking to find the best way to phrase this. So pardon me if this is not the best one, but I hope this connects. Forgiving world, where error can be retried, APIs are predictable, and latencies are measured. you know and I'll go deeper into each of this. But when it comes to physical world, it plays entirely different rule. Let's look for the 4 reason, and I'm going to go deeper into one of all of them and see why we see that there is a less room for retries, less unpredictability, or less irreversibility through all of these examples, right? um, when it comes to software, and I'm going to go with number one challenges we see here. Schemas are fixed, you know, in the real world. But when it comes to in the real world, no two factory floors are identical. There is a lighting changes, there is object moves all around, there's a people walk in the same workspace, there is a equipment getting rearranged. So when it comes to physical world agents, you can't rely on a hard-coded assumptions. They have to perceive and adapt continuously. That takes us to the next challenge. When it comes to digital agent, a bad output is more like an inconvenience. If a chatbot is responding to you not to the point you are to your question, it might create a little bit of a customer dissatisfaction. But when it comes to physical agent, a bad action means an injury. That is a massive challenge.
Mm.
Every action when it comes to physical agent must be bounded by a real-time safety guardrail. And that adds more challenges here.
Mhm.
Let's move on to the third challenge. When it comes to digital agent, you can tolerate a latency, a second of latency. Now you probably argue, no, my performance are slow, customer is complaining. I get that. I'm not saying build a slow systems, but you still can tolerate. Imagine you building a physical system that takes 5 seconds to process for the next action. It has to act in like a human.
Mhm.
And this forces a hybrid architecture where you have a heavy reasoning running on a cloud and then reflex happening at the edge, which adds additional complexity when we build an agentic orchestration, because now you are adding two complete different paradigm and trying to build an orchestrations around that one. Finally, and this is my favorite, when it comes to digital workflow, you can retry API call. The API timing out, retry, right? When it comes to physical world, have you seen that a package is being undrop or a robot going to be uncollide?
Mhm.
Once an action happen, there is no way you can reverse that one. And that
Yeah.
raises the bar of everything has to go through a high reasoning quality, high simulation, high validation before you take any action. So these are my four challenges, and I'm pretty sure there are more. When you dig deeper into your industrial knowledge, but my four are like unstructured environment, safety, latency, and irreversibility. And that's why I say physical AI is going to be a new class of agentic orchestration that will have a lots of fun and lots of research coming in this space in next few months to a year.
That's interesting because you said something like physical AI will be a new class of agentic orchestration. And I think this quote resonates a lot. So, to the ones who are watching us that have no idea about what this is about, and they're watching us because they saw the notification, they tuned in, pay attention on that quote again from Abhishek. Like physical AI will be a new class of agentic orchestration in the future, right? So it's very predictive. I like it a lot. There is one question here that correlates AWS outposts, asking would AWS outposts be interesting for millisecond latency requirements in factories and warehouses? When you have these robots and you want to infer things with quality with a low latency, could you put an outposts rack and infer from there?
The answer is it depends. Um,
Hmm.
you know, a lot of these inference runs on a GPU workload, and that
Okay.
require even your uh, you know, edge systems that has a GPU compatibility. So in cases like this, I think we might need to look around other solutions like, and Dan can probably share more details about the Jetson devices. Um,
Uh-huh.
when it comes to CPU based compute requirements, yes, cases like this, Outpost could be a good, viable solutions there.
Okay. Cool. Awesome. Thank you.
Now, I gave you a challenge, and I hate to just give you a challenge and not give you some direction. Like I said, this is an area evolving, so I can't give you an architecture and say, please run it, for your workload. But we
Mm-hmm.
want to give you some mental model, and this is,
Mm-hmm.
um, you know, where we want to showcase like two different layers and see how these two works together. And always remember the first 10 10-15 second of demo that we showed, and how those orchestration happen there. In the top layer, you have this agentic orchestration where you have a high level thinking happening right there. And this is responsible for multi agent coordination, task decompositions, fleet wide learning, and long horizon planning.
Hmm.
Below that, we have this specialized agent tied to your business functions, such as inventory planning,
Hmm.
quality control, scheduling, routing. So, all of these domain specific task is being handled through these specialized agents. Now,
I
what
see.
this brings to the table is now you have a system that connects a specialized agent to your larger business functions, such as ERP systems, warehouse management systems, manufacturing execution systems. So now your physical system is not just working independently in the physical world environment, but through this agentic AI wrapper, agentic AI orchestration, is connected to the wider enterprise based system. And that's the value it brings to the table, right? So,
Perfect.
very, very important top layer. Now, let's go to the bottom layer, and we kind of dig deeper into that in last three session, which is the physical AI layer. This is the layer which offers you perception through camera, sensor, lidar, reasoning through VLAs, and action through the motor control and for operations like grasping and locomotions. Uh, so together, these two layer is building an enterprise-ready physical, AI automations for industrial scale workload. Right? Remember these two layers, because now I'm going to zoom into the top layer a little bit more and see how AWS can help. Right? So this is a complete developer to production journey of agentic orchestration. And I'm talking about the top layer, right? We start with the Kiro, AWS Agentic IDE for a spec-driven development. You probably have heard about Kiro in in a lot of digital space when it comes to software development. Kiro is also an excellent IDE for a physical AI development. We've been doing a lot internally for building a lot of demos for our customers. So do check out and see how it helps you your physical AI journey. uh, Literally what you do is you describe what you want in a natural language, and Kiro generate production ready code for you. It offers spec driven design, where requirement turns into executable code. You can also generate test cases. You can extend your software to follow a specialized rule functions that is very specific to your organization software development lifecycle. The bottom line is, with Kiro, you can convert an idea to a working agent faster with a very fewer bug. So it's really a great accelerator for you. And that's why I'm keeping this as our layer one. When it comes to
Hmm.
layer two of this offering from AWS, you have an agentic framework layer. This is where, once you have an idea, you want to build a solutions, you need a framework, right, to build and orchestrate multi-agent system. And this is where Strands Agent SDK, which is an AWS open source multi-model agent builder, can help you reach there. And C2 is going to go great deeper into this category and show you some working demo here. And then we have this bottom layer, which is extremely important for deploying and scaling your agent through Bedrock AgentCore. So as you know, building agent is one thing, testing locally is another. But when it comes to running them in a production at a fleet scale, is completely different sort of problem to solve. Bedrock Agent Core is the production runtime purpose built for this agentic workload. It offers you agent core memory for persistent context across sessions and agents. It offers serverless runtime where you don't have to manage any infrastructure for hosting your agent. It offers identity and access for secure agents to system authentication. All of that you need to build your production ready agentic orchestrations around physical AI. And now the final layer, the bottommost layer, which is as I mentioned, I'm not going to go deeper into that one, but when it comes to synthetic data generations, model training and fine tuning, policy validation using simulations, all of those comes under this physical AI stack, which we have covered in a great extent in last 3 sessions. So with that being said, now that you have a little bit of idea around how this frameworks and architecture works together with physical AI to build an enterprise grade autonomous systems and offers this agentic orchestration, I'm going to hand over to my friend Dan to dive deeper into NVIDIA NeMo Agent Toolkit and see how that complements with and extend this architecture for our customers. So, Dan, over to you.
Cool. Just before that, there was a question. Which stack does the DDS belong to, the data distribution service? The Keto, the Agent Core, or the physical AI one?
So, in this case, DDS is going to go to the bottom one, which is the
Yeah,
physical
I
AI.
know. Okay, perfect. Thank you.
I can also talk about that before we jump to the dance portion. DDS is basically the middleware of the ROS2. So if you deploy one robot with ROS2, you basically already using the DDS. So we can cover on the DDS level on the physical device as well. So yeah, I just want to bring.
Perfect. All right. Thank you. So I think the microphone is now with Dan.
Yeah, great. Thank you, guys. I've also prepared a bit of a presentation. I'm not sure if we can share that here. I'm going to talk a little bit about and build upon what Abhishek has been talking about when it comes to agentic orchestration. I've tried to keep it so that there are as many pictures as possible without sacrificing too many details. So hopefully it'll be an easy follow through on this presentation. Um, I'm going to talk a little bit about NeMo Agentic Toolkit, which is sort of NVIDIA's go-to framework for building, deploying agents easily at enterprise scale, and about why this sort of framework is so important and critical for agentic orchestration, which is basically how we manage potentially many autonomous AI agents, right, which can be a recipe for chaos without effective orchestration.
Mm-hmm.
So without much further ado, if we think about building agentic systems, right, maybe this is obvious to some folks. Maybe this is something that's just a part of this exercise where building these agentic systems can easily spiral out of control when it comes to complexity, right? You're building these agentic systems, they're complicated. You not only have complications or complexity coming from the architecture itself with these different tools, different agentic models and roles in place, you also have issues with stochasticity. These large language model agents can be very non-repeatable or non-reproducible. So sometimes you get one output from the same input, from a slightly different input, you get a slightly different output. You might have issues where you have to kind of work together with fragmented solutions, right? Sometimes you build these things out, especially now with the help of LLM coding agents nowadays. Code growth and then review and pruning is always an issue, and trying to find ways to save yourself from duplicate work is
Mm-hmm.
also something that we need to keep an eye out on performance wise. So we also need to make sure that from a performance perspective, as we build out complex systems, we still maintain performant, efficient systems, right? And this still requires knowledge and keeping track of building such a complex agentic system. And these other aspects are also equally as important, right? So when we think about learning and adaptation, you put an agentic system out there, you test run it, you see how well it goes. It needs to be able to adapt, and then some things it can adapt to. Other things you as the user need to make sure that you're able to note in terms of failure cases or other cases where we would need to make improvements to the agentic systems ourselves. Safety, security, and privacy, I feel like in this age, we don't really have to talk too much about. We've seen some of the issues that have come up with security, for example, as well as with safety, and making sure that we have guardrails in place or at least mitigations in place to prevent that from happening. Enterprise readiness is another. From enterprise to enterprise, company to company, needs are different, right? data infer is different. Many things are different across industries and companies. So we need to make sure that these things can plug in relatively easily, but also provide the telemetry we need for observability across these different systems. And then finally, user AI interaction, right? This kind of goes not just beyond basically being able to speak and communicate with an LLM and the system itself, but also trying to make sure that there's some intent alignment so that even if you don't express your desires or wants as clearly, the agentic system is still able to tease out what you want, or at the very least follow up, know when to follow up and know when to clarify, for example. So when we think about a typical agentic architecture, right, these projects always start small. When I build these things, they always start small, and then a week later, I have no idea where to go because my code is across many different
Yeah.
repos and across many different scripts, partially written by me, partially written by Claude. So it's unclear, right? So you say you start small. You have an LLM, you have an agent, you have maybe 2 tools, right? Okay, great, easy, tractable. Okay, now we're going to have a fast API server. I realize my agent is not remembering past interactions in history that I might need it to for better context management. So now I need to add a memory module. Oh, wait, no, I still also need to figure out what's going on when things are broken. I don't have sufficient logging. I don't have sufficient reasons as to why certain things are timing out. So now I have to add telemetry. Now I need observability, right? Okay, let's keep going. I need to realize then, oh, well, I need to also have the most up-to-date information. So I might need a retriever, and then I might need a RAG database for my retriever. I then need to profile my system because if I'm eventually going to deploy it, running it on my MacBook, running it on a small VM that I have is probably going to be insufficient. So I need to profile the performance. And then I realize, oh, wait, it's not just going to people who are going to borrow Dan's PC or Dan's Mac and just run the agentic system there. They need to evaluate it on their own. So I need to create profilers. I need to have evaluation systems in place and data sets of benchmarks and environments to benchmark this agentic system. And so you can see how this kind of quickly spirals out of control, even from a very simple ask of wanting to build something to eventually deploying it and trying to understand how well its behavior goes on through time, right? And so you then have to further optimize it. And then all these things can come from different sources, different frameworks, different aspects, different code bases. And it will drive you insane. I speak from personal experience. So the good thing about NeMo Agentic Toolkit is that it offers all of this kind of bundled up in one-stop shop. And it really gives you the tools you need. And even if it doesn't give you the tools you need off your bat, it makes it very easy for you to build the tools you need in a very sort of easy language slash framework agnostic manner. And I'll talk a little bit about what that means shortly. So orchestration kind of involves all of this, all these pieces, and this is what NeMo Agentic Toolkit or NAT is sort of meant to target or help with. And so if we take a look at where this sits in the stack, so to speak, right? We have NeMo Agentic Toolkit sitting at the very top. There's the framework and scaffolding in the middle. And obviously there's the infra, which is probably what NVIDIA is known best for at the very bottom. And so framework and scaffolding wise, you can see that, and I'll talk a little bit more about this later in the presentation as well. It's fairly agnostic to a lot of the different things that are out there. So I'll talk about that later. But you can see, at least from the NeMo Agentic Toolkit box, that with the agent, we have quite a few things in place, all linked together in a very easy to use and well compartmentalized way, right? You have everything you need for orchestration. You have your optimized agentic application. You have configuration interface. I'll talk a little bit about that as well as to how you can easily configure different behaviors, modules, functions, tool calls, etc. And these things are supported by anything you might need from MCP tool calls, MCP servers, REST, WebSocket console, etc., to a GUI interface or graphic user interface. You have all the different things you might need, for example, when it comes to memory, retrieval, and other functionalities for your agents, along with guardrails, authentication for your systems on a system level. And then obviously you have all these things that I mentioned in the last slide, which can make complex agentic systems a bit of a headache for the designer when it comes to profiling, evaluation, optimization, et cetera, et cetera. And so the NeMo Agentic Toolkit brings all these things together and is meant to work seamlessly with these different frameworks and scaffolds and also seamlessly with our infra as well. But the other thing I also sort of want to mention is that when it comes to NeMo Agentic Toolkit, like the main express goal is not to just make things easy, but also to reduce the kind of complexity of doing this if you were doing it solo, right? Or if you were doing it piecemeal, bit by bit, across your system by borrowing from different places, right? So like I mentioned, it's framework agnostic. It supports multiple frameworks, LangChain, LangGraph being probably the more popular ones, as well as others. And we're continuously striving to improve our support of these frameworks and potentially others down the road as well. We have evaluation systems. So you have your own customizable bespoke evaluation frameworks for agentic workflows so that you can make sure that you're targeting exactly what it is you want to target when evaluating your agentic systems. Observability, this is also a very big one, right? So when you build these complex agent systems, right, and then you deploy them in very complex settings, be it in physical settings or be it in enterprise or digital settings, you really, really run the gamut of not knowing what goes wrong. Something will go wrong, I guarantee it, but you won't know what will go wrong, especially as your system becomes more and more complex. And this is one of the key features that NAT offers, or NeMo Agentic Toolkit offers. Profiling is also very important. Your complex agent system can stall, especially as it grows with the number of agents, modules, tool calls, and everything else you're plugging in. And then we also offer ways to optimize through your workflows, right? We won't just say, here's a profiler, your performance is bad. We'll actually help you find ways through NeMo Agentic Toolkit to figure out what's going on here, right? When it comes to either optimizing the hyperparameters that sort of tune your system, be it specific to the LLMs themselves or otherwise, but also through our other sort of product offerings of integration with like NVIDIA Dynamo, for example, that accelerates inference. And so safety and security is also not on the back of our minds either. It's also at the top of our minds. We want to make sure that there are ways we can not only identify vulnerabilities and also mitigate them, but also in some sense allow folks to easily profile the risks to them ahead of time and also red team them as well before deployment. So if I talk about this from a more, let's say, system architectural diagram point of view, right? You can think of NeMo Agentic Toolkit workflow, and I promised pictures, so hopefully this is a good picture. If you think about NeMo Agentic Toolkit workflows being in the beginning, right, the different components or aspects of these are just sort of some of the examples that are here. So you have an end user, and the end user is using, let's say, or designing an agentic system through this sort of toolkit. You have NeMo guardrails, which we offer to help serve as kind of buffers, right, or defenses to make sure that conversations are staying within allowed bounded usage of a conversation, for example. We also have other things, for example, that help speed up when it comes to optimization. So I mentioned NVIDIA Dynamo, which in terms of helping accelerate inference, for example, is just one aspect. We have NeMo Evaluator and NeMo Retriever to help with things like staying up to date or fetching the relevant information, storing the relevant information, along with evaluating our adjacent systems and making sure that they are aligned with the goals that we're trying to achieve. And then obviously we also have ways through our data flywheel, also through the NeMo general framework that supports NeMo Agentic Toolkit, right? This means offering ways we can fine-tune models that you want to plug into the system, right? Rather than using just plain off-the-shelf models, you might want to fine-tune them. You might want to train them. So we have NeMo Gym and NeMo RL to help do state-of-the-art post-training for some of your agents or LLM models, and we make it easy to do so. And then NeMo Customizer, which hopefully makes it easy for folks to fine tune and sort of choose how to easily to fine tune these models, how to use them in your toolkit. And so this kind of overall tries to offer a sort of system architecture view of how exactly you can pull different things from other parts of the NeMo ecosystem, all the way including things that we offer from other frameworks like Dynamo and other things, but also in terms of the very open source models we offer, such as Nemotron, for example, to plug into your system as well. So I'm going to talk just very briefly about how NeMo Agentic Toolkit works, right? Like what exactly is the foundational building block and what is key to sort of its flexibility. So the foundational building block is really just a function, right? You throw something in, you get something out. That's essentially it. And when we thought about designing NeMo Agentic Toolkit, the reason we focus on the function as the sort of foundational building block is that we want to make sure that it balances flexibility with also customizability and also along with standardized sufficient usage of some of these functions so that people can not only choose to design what they want to do, but also make sure that people can use them and agree on using them in certain ways. So when we think about these functions, right, there are sort of three properties to kind of define them. One is an input schema, which is really simple. Like when you put your LLM into a system, what kind of data does the function accept? And this can define many things such as like, oh, your typical LLM only takes in text. It can be poetry, it can be Python, it can be whatever you might want. Some cases you might want images, right? Some cases you might want videos. And we also have blueprints that allow you to do video summary and video report generation as well. The description is basically describing what the function is meant to do. Given some input data, what is the function meant to transform or operate on that data? What is the function meant to do? And finally, the output schema, which defines what exactly is the output the function provides, right? After set transformation, what does the output look like? And so there's this body of function that can basically execute any Python code. It provides a unified interface. And again, this is why it's sort of framework agnostic, because it's just basically using this function as the building block. And you'll see this all throughout our toolkit. But this will make it so that it's very easy to customize and also very standardized to use. And the thing that's used probably the most, and we also provide a lot of support, there are other paradigms. We also offer NeMo Agentic Toolkit, but as part of the orchestration, the most commonly used by far kind of sort of way that AI frameworks enable LLMs to solve these complex tasks are sort of different paradigms for thinking. React is probably the most common one. I think it stands for reasoning and acting. And so basically, you give the LLM a prompt that basically allows it to operate in this loop of thinking, observing, and then acting, right? And so this way, it's a very common tool calling system. Basically, you give the LLM this sort of prompt along these lines. There are many other different sort of variants of React, like Reflexion and others, that kind of build upon the main basic concept, which is how do I get the LM to understand this question, output a reasoning trace, think about it, have it understand what it's observing, and then proceed to work on the task iteratively, right? So given this question, these tools, which tool do you need to answer this question, essentially? The agent's going to execute the tool. Given that input, the process will loop. And again, in the NeMo Agentic Toolkit, you can define things like the tools it has available, the number of max loops or attempts it has before the system stops. Otherwise, you're just going to wait on your answer forever, and many, many different other aspects of the process, right? So the process will loop until LLM gives the answer, and then the agent and all the tools are implemented using the same LLM framework under NeMo Agentic Toolkit. And so this will just basically be how you start building your agent system bit by bit, one by one. If we think a little bit about how these things can be wrapped together, this React agent, so that everything's a function, going back to what I was saying about it, a function being the sort of foundational building block. So the agent, as well as the tools that it calls, are defined as functions, right? Each of them will have an input-output description. And so instead of calling the function directly, what NeMo Agentic Toolkit does is it will wrap the function in the correct tool object or LangChain, for example, tool object here. And so this way, there's a sort of universability of kind of like functions being everywhere. Being it can be the agent calling itself, it can be the tools, and anything. And that's sort of what makes it very flexible. And it kind of shows you how essentially this way you can have many, many degrees of freedom when it comes to customizing how you want your agentic loops to look like, how many agents you want to put in there, how agents communicate with each other, and in that whole process, how many times they can call tools, what kind of tools they can call, even including tools that you build yourself. And so if you think about the framework and other capabilities with the frameworks, you can just think of it as tools wrapped around as functions, right? So then users can basically mix and match the tools they have available in different frameworks. It doesn't just have to be, for example, LangChain, like I was saying earlier. So the toolkit can easily wrap the different frameworks together, and then it can do seamless communication between different features of these different frameworks as well, which offers a sort of additional degree of cross diverse flexibility for people who want to use it. And there's sort of no code changes required on the implementation or implementer of the React agent. So everything just works as function calls, which is why the function is kind of the foundational building block. So it offers people who want to create systems, be it early users or people who are developers, all the way down to people who might be looking for enterprise sort of use cases as well. I'll talk a little bit about addition building blocks. Obviously, we offer some more advanced capabilities too for more specific cases. And these kind of building blocks, you can sort of think about mixing and matching different frameworks together, and they can sort of talk with one another. So these building blocks kind of provide unified frameworks, like I was saying, the sort of function calls for common components in Unix systems. You can get super fancy. You can get embedders and retrievers in case you have like a need where, let's say, you need to search the web, you need to get up-to-date information, you need to have some form of a database, and you need to have some way of looking or checking against that database to kind of find and retrieve the right answers. You have memory, like I said earlier, in case you have histories or the history of conversations you have or the interactions with the agents are also important for the agentic system to work. And what's cool is that you can sort of swap these components at runtime, right? And a lot of these things will allow for additional flexibility, not just in the design, but also in the running and evaluation of these agentic systems. And you can sort of then test all sorts of things by just plugging things in and then seeing how results change out. So that really comes down to how much freedom you give the user, and we tend to give a lot of freedom and customizability to the user. And so I'll probably conclude by talking a little bit about a more concrete example as to how this might work, right? So say you want to kind of come up and start with a agentic workflow. It always starts and centralizes itself around these sort of YAML files, these configuration YAML files, right? So you can see on the left here, for example, you define several things like, for example, what kind of functions you might want to use as tools. You have a indexing RAG tool. You have a LangChain RAG tool. You have a semantic kernel RAG tool. The kind of agent you want, you can specify React agent in this case, or other agents. There are other agents available as well. We specify React agent, and it's a React agent that specializes in calling tools. And then you provide the tool names that we've defined earlier that kind of you just feed back in for it to be aware that it has these tools available for it to use. So you define your agents. They can be React, Rewoo, tool calling, sequential. You can have parallel agents. You can have custom agents you can build. All these are possible. You have system prompts and instructions. You have functions, like I said. You have memory providers, models, et cetera, et cetera. And you can insert your own models as well if you'd like. You can sort of train models using the larger NeMo ecosystem. All these are sort of possible. And so once you define
Interesting.
this YAML, and you kind of load the workflows from your YAML, it's just that simple. You define this YAML, you load the workflow from your YAML into the workflow builder, and then it'll just buzz along on its own. And it's really just that simple. Now,
Yeah.
like I said, there are certain advanced configurations, but we also leave that to the interested user in our sort of very, very well thought out documentation as well.
Cool. I see that in that JSON you have on your slide on the left, you are choosing the Llama model from Meta, and I think that's why Bedrock is a key service, right, Abhishek? Because it lets you choose the model you want, right? So that's why I think Bedrock is strategic for that because you have the freedom of choosing models that are managed. And where is this processing performed then? Is it on the local side? Is it on the cloud side? There is a discussion here in the chat that I would like to bring here. Someone
Mhm.
posted for a robot, all that must be done with the lowest low. Oh, look who posted that question. Look at that little avatar. Looks like someone I know. For a robot, all that must be done with the lowest latency as possible, right? So, Sean Kirby, which is not on camera, but he was on camera for our previous episode, he said, low latency is indeed key for robots, although there are patterns where some higher level, longer term planning can be done at lower latency, offloaded to the cloud. And then, is a hybrid approach reasonable? Tasks requiring larger models go to the cloud, and tasks requiring speed are performed locally. So tasks that require larger models with Llama and billions of parameters can go to the cloud. And then Sean, absolutely, there is an approach we've seen more commonly for both cost effectiveness and good separation of concerns. And then Victor said, "Hello AWS." Hello Victor.
Yeah, it's certainly very important, right? When especially with physical AI workloads, you need to determine what operates best locally versus what operates best in the cloud.
Uh huh.
Our orchestration hopefully helps with particularly things that occur in the cloud, but for more short-term things, that'll come down to the specific consideration of whatever use case you're looking at now. But this orchestration is meant to be universally amenable. So that's something we keep in mind for both for agentic systems across not just computer use and simulation, but also potentially physical as well. So that's certainly something we have in mind.
Mm-hmm. Cool. All right. So now we move to C2.
So, am I audible?
Yes, loud and clear, sir.
So, thank you so much for recapping the agents, growth, training, tuning, and simulation before this session. I'm from Strand Agents team, and now we have a new organization in GitHub named Strands Labs. In this organization, we have at the moment we have 3 repositories, but there will be more repositories to come. Internally, we have been building agents for ourselves. We use all of the open source SDKs externally, and then we come up with our solution to answer that for our internal deployments, which we process trillions of tokens today using Strands, including Kiro is one of the clients of Strands. So, but we are taking a serious step for physical AI, and we are asking ourselves, what if any developer could build a robotics application with few line of code, which in Strands we focused on the simplicity, how you can scaffold an agent faster and how to deploy to the production in minutes. AgentCore comes to the scene for observability, other primitives than mentioned. We also have the same in AgentCore. But today is the topic of vision language action models and world foundation models I want to touch upon. We support Groot as one of the main providers in Translabs robots today, which with 10 line of code, you can define a robot, which in this case going to be seen to an agent as a G1. Type of it is a unitary G1. You can see in my behind. That robot itself became a tool for an agent. It could be any framework you would wish. It could be any runtime, including AgentCore runtime. After you type this 10 line of code and start running it, you will see your G1 in the simulation start trying to pick up the red block using the Groot 1.7, which is the latest update on the Groot. So in our SDK, in our robotics library, we want to be able to use all VLAs, but I want to zoom in a bit. What is the VLA and why I'm talking about it? We were thinking about existing agents we have and existing robots. You can connect an existing robotic system using ROS2, which we had a question in the chat in the YouTube live stream I saw. Where is the DDS comes into the scene? DDS, Cyclone DDS and Fast DDS, if you want to see, they are middlewares for ROS. We support all of them today. And you have an agent to approach a problem with off-the-shelf abilities of a robot versus unseen tasks. We are tapping into unseen tasks with vision language action models. You can program a robot to walk in a room using a normal policy. But if you want a dexterity required tasks or a deeper locomotion motion, you might need a vision language action model, which I prefer to explain that today. In this example, you can use Groot 1.7, it's early access today, or Lerobot-based policies. So imagine that you ask your agent, use G1 as a tool to pick up red block using Groot policy. This uses the existing policy you already spinned up. But maybe you have a target model, which in this case, small VLA, as an alternative for it. You can use the same agent interface without changing any line of code, which is the power of it. So let's talk about how we collect data. Either you can teleoperate a robot with some hardware, or you can dream about it. We will talk about dreaming in a second. Let me walk you through the steps. You collect data with some teleoperation. Based on that data, you export that as a Lerobot dataset format. That means if you follow our initial first 3 live streams, you will be able to train Isaac Groot on AWS immediately based on that dataset you collected. But how we can tie all of these into one agent is another question, right? What kind of tools we will give? What is the data type? What is the episode number? Something like that. But in robotics, the biggest problem is data number of data we have today close to the realistic, photorealistic rooms. In this example, I have 2 videos. On the left, you see a standard open arm trying to move the orange from out of the plate. It's just like a couple seconds of the episode. On the right, I have many objects being picked up by the gripper. That's the data set we generated. But in this video, nothing is real. It looks real. It feels real. The actions are performed with a World Foundation model, World VLA, or which policy you would love to pick. But these are not real in that sense. After you collect this number of episodes, in this case, I put some prompts here, right? Dream 500 variations of the same scene with DreamGen. It's an NVIDIA product. And post-tune Groot 1.7 based on the augmented set. Maybe it's good to explain. This 2 lines working, and it's using AWS SageMaker for training. using S3 for storing the dreamed episodes, using again AWS Strands robots to deploy to the hardware. If you think you have a mesh of your room, 3D scan of your room, you can simulate in that exact same scene millions of times in cloud environment, which
Mhm.
AWS is the best place to do that. So you can amplify your data, you can train your model, and then deploy to your runtime immediately. So we talked about cloud and edge, but I want to talk about how to continuously connect them, how we can make sure our cloud reasoning is actually making a real robot action on the entry point. So we use AgentCore for deploying any framework-based agent. It could be Nemotron, sorry, it could be NeMo agent toolkit, it could be Strands, it could be LangChain, but we support all of them. And you collect your agent inputs and then you pass through to the edge device, which is AgentCore is an amazing device for today. But when we deploy these systems to the real world, how we are going to orchestrate this? I want to give you a small soccer game example here. I gave a 5x5 game idea, and I have 5 robots on the left side, 5 robots on the right. These are real code, by the way. You define a peer ID for each of them. You can see I leave the ball to the striker. Striker says, "Oh, I'm going to pass the ball to the mid." Mid says, "Yeah, I need to send back to the striker. We need to shoot because we need to make something done." I think Abhishek mentioned industrial use cases, right? Making something done is our industrial goal, and agents are tapping into this fleet management naturally. We don't have to think about how to orchestrate n number of robots, how to bridge the sim to real. We just care about how many devices we have, which protocol they are actively using, and how to collaborate on all of them. I put some images here to just give sense of um, once you start running a simulation, what you would expect from your environment to actually showcase. And in this case, I have some videos of my RL environment. My agent is generated environment and tries to move in, which fails. These are data sets. On top, you can see a Mujoko sim for simulation, and you can see another Isaac sim environment to the bottom. So I have like a small dashboard of how it's going to look like when we ship a small dashboard for that.
Mhm.
But so far, these are the things I would love to mention about Strands Labs and agentic orchestration. Yeah, yeah. I hope
That's
this.
very interesting. Yeah,
Yeah.
yeah, that's incredible, C2. If you want to come again on the next episode to continue talking about these cool things, these interactive slides, I was navigating over some links while presentations were being performed, and because we still have 2 minutes left, let me just show some links I opened while Abhishek and Dan and you were speaking. Um, this is keto.dev. It's the Keto IDE where you can with ease create agentic workflows, orchestrations by using vibe coding or spec-driven coding. It's a you see keto.dev. You can download. You can get it. This is the NVIDIA NeMo that Dan talked about, a comprehensive toolkit to build, monitor, and optimize AI agents across their lifecycle at enterprise scale. I like this. This is the Jetson tour that Sichu spoke about, and you can get one of these devices, and you can a compact powerhouse for advanced AI and robots. So I just wanted to show that just to complement some things that you spoke. We have great interaction in the chat. People saying that I love the VLA plus strengths example. Cool example, C2. Someone asks if we can collect data from the cloud, and Naj hop in the chat and said, yeah, if you utilize NVIDIA Cosmos, you can create synthetic data, and Cosmos can be hosted in the cloud. We talked about Cosmos. Was it in episode 2, Abhishek?
It was episode 1, actually.
Episode 1. Yeah, so
Yeah.
the link is bit.ly NVIDIA EP1. If you just do EP1, EP2, EP3, EP4, you can have the access for these episodes. It is 5:59. We are at the exact 1 hour mark. Does anyone wants to add something before we wrap up? Thank you a lot.
Raf, I just want you to bring this last slide. I want to show the QR code that C2 mentioned. Very important, especially the
Mm-hmm.
strand slabs.
Mm-hmm.
So, if you are building your physical AI system, I like you to take a snip of this one. This is the strand slab. There is a blog as well as there is a lab, first and the last one. Take a screen print of this one. This will help you to get started. We also have the guidance for building a full physical AI system that you probably have seen in other session we talked about. So take a look at these resources. This will definitely help you get started with your physical AI journey.
Perfect. The hands-on lab is very nice. I'm posting them on the chat here, just for people to be able to click rather than having to scan. So the links are all there, but it's in the chat, so they have clickable links. And I think that's it. So thanks a lot for everyone for participating, and see you next week. We're gonna have some interesting guests next week, and stay with us for more learning with NVIDIA, Physical AI, and AWS. Thank you a lot for watching.
Thank you so much.
Thanks Abhishek, Dan, and
Thank
C2
you.
for as well.